we want to get into something called the inverse function of the inverse of the function. So the inverse of a function is defined by f inverse of x. And you have to take a guess. What would f inverse of x equal to? Nolan, lad.
1 over f of x.
1 over f of x. That is the most common mistake. But naturally, I'm glad you made it. Actually, that's what it'll come to one's mind, when we look at the function f inverse of x. And 1 over 2, move that 2 to the numerator, we got 2 raised to -1. That's what we did earlier. So it is only natural to come to that conclusion. But I want you to keep in mind, if it is 1 over f of x, oh, there's a switch here. F of x raised -1. Good. See the difference between the two? So you take the entire function, raise it to the power of 1, but we denote it in a different way. So you may say, well, what is the difference between the two? So, if you pick a value x, we get a corresponding value y by plugging it into a function. In this case, that function is linear. So we have a linear function, a straight line. We don't just say that is y equals x plus 1. Keep things easy. Good. So that is our function. It takes a value x and puts it over to 1. Let's take a bunch of x values. Give me an x value between -5 and 5. 2. Okay. Give me a value between -5 and 0. Negative. What would we get when we plug in -3? When you plug in 0, when you plug in 2. Good. All I did is plug in values. If I plug in -3, I get -2. 0, I get 1. 2, I get 3. If that statement is true, and you try to solve for y equal, excuse me, solve for x, when you plug in y equals -2, what should you get? -3. If you plug in y equals 1, what should you get? 0. If you solve for x by plugging in y equals 3, what should you get? 2. So if you go in this direction, you should be able to come back in that direction. Agree? So pick a value of x, you went up, you got to one direction. If awful bad, if you start here, going that way, it's the other direction, but the equation matches. But it'll only work provided the function is what we call 1-to-1. In other words, one x value has one y value, 1-to-1 connection. There is a, excuse me, there is a test that you can use to determine if a function is 1-to-1. Now, where's the sentence? How do we determine if an equation is a function? Think of baby cow. The vertical line. Still not big into this. So, to determine if an equation is a function or not, we use the vertical line test. If you're not reading the less model such. Do we agree that that is a function? Yes. If you pick a value for x, let's say 2. That's -2. Yes. And both of them get some value. What? Right. And if I ask you, plug in x is equal to 2, let's say that value is hypothetically. What is the value of y? 3. Plug in x is equal to -2, and I'll ask you, well, what is the value of y? 3. One direction, backwards. If I change and I say, if y is 3, what is the value of x? And what would you say? Positive or -2? It has 2 values. It cannot have 2 values if you want to find an inverse. This function is not 1-to-1. 1x doesn't result in 1y. Do we like how? That is horizontal lines. If you draw a line through a curve, and if it touches more than one point, then that function is not 1-to-1, not a 1-to-1 function. A function that is not one-to-one will not have an inverse. So there are ways to find one. If you play with it beyond the scope of this book, I won't get into that. So you can't find its inverse directly. Over here, then, I can't find the inverse easily. From the picture, x goes to y, y goes back to x, easy. So start with y equals x plus 1. Yes. That is f of x. Yes. I plugged in -3, got -2, and then I asked you, well, if you plug in -2 for y and you solve for x, what will you get? And you gave me -3. Yes? So we have to go backwards. We have to look at it from another side. So flip x and y. Yes. Just look up. Next step. Solve for y. If you solve for y, what would you get? Y equals x minus 1. Now, plug in -2 in that equation in step 3. What will you get? -3. Plug in 1, what will you get? 0. Plug in 3, what will you get? 2. So that equation goes in this direction. Yes. You solved after doing this step, it brought things back. Agree? So I'm going to call that F inverse of x. Good. So F inverse of x would take a value of x, put it to the y-axis. Sorry, F of x will take a value of x, put it to the y-axis. F inverse will bring it back. Good. Okay. Now, why did I bring this up? Can I erase? And 3.1. We had an exponential function, y equals e raised x. When you plug in 0, what should you get? One. So in the inverse function, when you plug in 1, what should you get? Negative. So x is equal to 0, 1. You plug it in e raised x, you get y equals 1. Yes. The inverse function must bring it back to 0. Agree? That's exactly what that did over there. So what should you do? You confused?
Like, well, like I understand property, it's just like wait, like I don't know what you're asking.
I mean, what would the inverse be? So over here, So -3. This equation got it to -2. Yes. When I flipped it and I asked you, well, if y is -2, what function will give you x? We solved for it. And that function is x minus 1. Can you think of a function which will do the same here? In other words, if I plug in 1, I need to go back to 0. X minus 1. Okay, good guess. Louder.
X minus 1.
Nolan says x minus 1. Well, if you plug in 1, which is y, sure, 1 minus 1, 0. Agree? X minus 1, is it a line? Yes. Okay. If you, let's say, look at it from this way, what does it look like? Think of a ladder. If you're looking at the ladder from below, what does it look like? Still a ladder? That's an easy question. Yes. Linear line, if you look at it from beneath, it is still a linear line. Now, if you look at it from the side, is it still linear? Yes. If you look at it from this direction, it is a curve, correct? Nolan said to get up, all we need is x minus 1. X minus 1 is a line. So the ladder is no longer a ladder. It looks like something else. What's the index? That's where I'm going. I'm asking you to take a guess. Okay, so common mistake that people would write the inverse of e raised x to the e raised negative x. That's not that easy. E raised negative x, if you plug in x is equal to 0, you will still get 1. But it is not a proper inverse. You should be able to go back and forth if you have a proper inverse. I used 4 steps here to find the inverse of that function, x plus 1. Linear functions, you can easily find the inverse. Quadratic functions, simple ones, you can find the inverse easily. But when you get to functions such as exponential, sine, cosine, finding an inverse, not so easy. So what we do is we simply call the function using a different name. Let's say f of x is equal to e raised x. F becomes f inverse. E becomes ln. And ln is an entirely different function. So we all know e raised x. Right? So the curve is going this way. So some of you can visualize it, you're an artist. But if you look at it from the other side, the curve has to go that way. So ln of x Do you see how those two are related? The curve that goes up was here, starting at negative infinity, going towards infinity, longer x is natural sum of x. Yes? This, on the other hand, is e raised x, the exponential of x. E raised 0 is 1. What is the value there when x is 0? When x is 0, not that. 1.
When
X is 0, this can.
oh, when x is 0, it doesn't.
It doesn't keep going. It doesn't go anywhere, it goes along negative or toward negative infinity. Yes? What do we know about an exponential function? An exponential function will get closer and closer to 0 as it goes to negative infinity, but it will never become 0. Same argument here. I plug in 0 in an exponential, I get 1. Which means when I plug in 1 in the inverse, I need to go back to 0. Yes. Nolan's initial guess was x minus 1, but x minus 1 is a line. That the inverse of a line is a line. It has to look exactly like a line. Does the function satisfy that condition? But if I plugged in x is equal to 0, I got 1 in e raised x, which would mean if I plug in 1 for logarithm, I must get 0. Yes? X is equal to 1. What is the value of y? 0. 0. Okay. Table. Give me a value, a whole number between 0 and 3. 2. Okay. A real number between 0 and 2. 4 is not between 0 and 2. Did you say 1? Oh, my bad. Okay, y equals 0, e raised 0, 1. Yes? Plug in 1, you get e raised 1. We know from last time it is 2.781. 7.825. Plug in 2. 7.389. Yes. Nolan's initial function, x minus 1, if that were to be the inverse, when you plug in 1, you must get 0. Well, 1 minus 1, 0 works. Now plug in 2.7182. It has to take you back to 1, correct? Will it take you back to 1? No. 2.7182 minus 1 is 1.7182. So y equals x minus 1 is not the inverse. Let's say if ln is the inverse, ln of 1 must give you 0. Works. ln of 2.7182 must give you 0. 0.99999. Why am I not getting exactly 1? It's decimal rounding. If I plug in 7.389, what should I get? 2. One point nine 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 nine, which is 2 approximately. So is ln of x the inverse of e raised x? It is. Okay. Good places.